iComMa is a new 6D camera pose estimation method by inverting 3D Gaussian splatting. 6D camera pose estimation involves determining both the position, which means translation, and orientation of a camera in 3D space relative to a scene or object. This task is typically accomplished through computer vision techniques where distinctive features in scene are identified and matched across images, enabling the computation of the camera's pose based on these correspondence. The translation component represents the camera's location in 3D coordinates, which are XYZ, while the rotation components describe its orientation using methods like rotation matrices or quaternions. This estimation is fundamental for applications such as augmented reality, robotics, and 3D construction, facilitating accurate rendering, navigation, and interaction with the virtual environment. This iComMa framework integrates traditional geometric matching methods with rendering comparison techniques. A key feature of this approach is the integration of a machine strategy, which significantly enhances the effectiveness in addressing challenging initial states. Additionally, the adoption of a render and compare method ensures the accuracy of the optimization process in the final stages, which is crucial for downstream applications of pose estimation tasks. The experimental results demonstrate that iComma effectively balances the robustness and accuracy of camera pose estimation, making it a valuable tool for tackling the challenges of complex pose estimation tasks. They also have a GitHub repo where they have opened the weights and source code and also have given some of the training and installation instructions which you can go through, and I will drop the link in video's description. But you would need a good GPU in order to run it locally. If you look at this diagram, this gives you a bit more information around its query image with an unknown camera pose. So what is happening here is that whenever a query image is given, if you start from the left and there is no known camera pose there, iComma accurately estimates it by inverting 3D Gaussian splatting from a known initial pose, which is the step 0 as you can see. The gradient information inherent in the differences between the query image and the rendered image, which are overlaid in this above figure as you can see, with a higher degree of overlap indicating more accurate pose estimation, is utilized for iteratively optimizing the camera pose. If you compare it to iNerf, this method not only employs pixel to pixel comparing but also utilizes 2D key points matching, which are connected by blue lines in this figure. As a result, this method is capable of precisely estimating camera pose even under poor initial conditions such as large angular deviations. Now, the this is a pipeline of iComma, and if you look at this pipeline, this is actually quite interesting. Now, what is happening here is that given a trained 3D representation of the scene, which are parameterized by this theta and a known camera pose, the objective is to estimate the camera pose t on an Curie observation Q. Now, given this initial camera pose, iComma iteratively optimizes to estimate the ground truth pose associated with the Curie image. So the entire framework is differentiable, enabling the optimization of camera pose by utilizing the gradients derived from minimizing the residuals. And there is a lot of good stuff happening in this one. For example, if you look at these experimental results, these are the visualization results of pose estimation, displaying the pose estimation results by overlaying Curie images and rendered images. It is also to be noted that for the initial poses, they have only provided the rendering results from iComma, as the initial pose for iNerf are consistent. For iComMa, during the initial stages of pose estimation, they also visualize the top 20 key points matching with the highest confidence detected by low FTR. So key points in this queue image are depicted in the green, as you can see here, and the other ones are only blue. But really amazing sort of results here in this pipeline. There are a lot of things which are happening here, but I'm not going to go into the further detail. I will drop the link to this method in a video's description. The thing to be remembered is that this is a method to address the 6D camera pose estimation problem in computer vision. That's it, guys. I hope that you enjoyed it. Let me know if you have any comments. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.